is even, so I will solve example for 18. This question is to compare whether the averaging by section is related to conditional expectations. First of all, the number of students in Class A is n. Let's define the scores each student received by the following variables. Let's define the score each student received by the following variables. Then, the average score of A class is expressed like this. Let's split the Class A into several sections. At this time, NS is the number of students in section S. The average of these sections can be obtained in the following ways. To understand this, let's solve a simple problem. The number of students in section 1 is 10, and each student's score is given as follows. What is the average score in section 1? After adding all the students' score, the average in this section can be obtained by dividing by the number of students. If calculated by mean of averaging this section, the value of 8 may be obtained. This time, when the number of students and the average value for each section are given, let's solve the problem of getting the overall average. Example class are divided into two sections, and the total number of students is the sum of the number of students in the two sections. How can we get the average? There are various ways to solve problems. First, there is a way to list, and if you got the scores of each student, not the average of the sections at all the students' score, and then divided them by the number of students. In this question, however, the average of each section has been given, so it is simpler. First, how many students in each section are compared to the total number of students? At this time, you can multiply the average value of each section by the percentage of the total number of students. If you add all the values for each section obtained, you can get the overall mean value. If you solve the problem through this process, you can get an average value of 7. Let's take a look at the progress we made so far. What is the meaning of multiplying the average value of each section and the students' ratio? It is defined as this weighted average. The weight is proportional to the number of students in each section and equal to ns over n. So, how does it relate to conditional expectations? Let's look at the situation of randomly selecting students from Class A. The probability that students will be selected is 1 over n. Now, two random variables are considered. In this case, the mean is m, and in section S, the mean is defined as follows. Y equal S means when a student in section S is selected, and all students in that section have a 1 over ns change of being selected. The example problem solved the problem assuming that the total number of students is equal to section 1 plus 2. Since section 1 has 10 students and section 2 has 5 students, the total number of students is 15. When any student is selected, the probability of being a student belonging to section 1 is 10 over 15. The probability of belonging to section solve the problem again in example 2 as follows. The average value obtained in the way is 7, the same as the previous value obtained. The point is that the weight of the average value varies by the number of students. So far, we have only worked out 2 sections in detail. But as the sections increase to several, it is necessary to see how much each section affects the average value. The key to the solution related to the number of students. Thanks for watching.